Solving logarithmic equations. All right, so technically this video is solving logarithmic equations with a single logarithm, but we have to talk about logarithmic equations as a whole before we can talk about just a logarithmic equation with one logarithm. I'll be referencing this page right here in both this video and the next video where I talk about logarithmic equations that have multiple logarithms. So both videos will have this page reference. So to begin with, a logarithmic equation is, you guessed it, it's an equation that contains at least one logarithm. That's what makes it a logarithmic equation. So we're talking about solving equations now that involve logarithms. There's a few important logarithmic facts that you need to know before we can move forward with this idea. The big, super important one, which isn't as important for single logarithms, but it is important for multiple logarithms, is that if you have two logs set equal to each other and they're both the same base, then their insides can be set equal to one another. And we should ask ourselves why always. So we should give a reason. If I have log base b of m, let's go ahead and put him in parentheses, of m equal to log base b of n, and we then try to do the loop-de-loop method. So we're going to do the loop-de-loop. We're going to rewrite this as an exponential. This is going to be weird because we have to take one side and treat it like a log and the other side like it's a whole thing. So here's what we're going to do. All right, here is my base. Boom, boom, boom. Here's what I'll be going across the equal sign to. And back again. So my base is b, across the equals, raised to the log base b of n is equal to back again and back again. Start at the base, across the equals, back again, is equal to m. All right. And one of the rules we have from our logarithmic properties is that if you have b raised to the log base b of n, that, well, it's x, we say x. The rule looks like this. If you have b raised to the log base b of x, it all cancels and you just get an x. In our case, it's not an x, it's an n. But regardless, these things cancel. You're left with n is equal to m, which is exactly what we were hoping for. Move these up a little bit. So if you have two logarithms with same base and it's one logarithm on one side and one log on the other, you can set those insides equal to one another and solve that equation. Because if they're equal, if you have two logs equal to one another, their insides must be equal, as proved right here. The other really big important thing that we need to remember about logarithmic equations is that the base and the inside of a logarithm cannot be negative or zero. Both the base and the inside of a logarithm need to be positive. This also brings up a really important thing that happens with logarithmic equations, and that's that we have to check every single answer for domain issues. Because logarithms have domain issues, there's times where we do all the math right, and one of the solutions we get from doing all the math correctly ends up not working. So every time we do a problem that starts with a log in it, we need to take our answers that we get and plug them back into the original equation to make sure that they don't cause domain issues. I'll write that down. All right. All solutions to log equations must be verified in the original equation to check for domain issues. We'll be doing this along the way. All right. In general, there's going to be two different types of log problems. With a single logarithm, if there's only one log in our equation, which is what this video is supposed to be about, that's going to be what I call a type A logarithmic equation. It reduces itself down to something like this. You have a log on one side and a number on the other side. In which case, you do the loop-de-loo. You do the loop-de-loo, you rewrite it as an exponential, you solve that equation. Then you check your answers. That's all this says. It says solve, check answers. The big important part are these steps 1 and 2. So with a single logarithm, you're going to end up with a type A for certain because there's only one logarithm. So you can't end up with a type B. But there are going to be problems in later sections that have this type B format. And we will talk about those. But for problems that only have a single logarithm, you want to get it down into this form here. Logarithm equals a number. For example, if we were to have log base 2 of 7x minus 5 equals, I don't know, 8, we would then have a type A. Right? The way we would rewrite this, start at the base across the equals back again, would be as 2 raised to the 8 is equal to 7x minus 5. And then we would solve that equation. Real easy to do, super simple algebra. I'm going to go ahead and just highlight this so that we know this is just like an example here. Boom. All right. With our single logarithms, that's what we're looking to do. We're just looking to loop-de-loo. So let's try a few of these. Solve for x, give an exact answer. My goal is to get this to be logarithm equals a number. That's the whole point of type A. We need to use algebra oftentimes to get it into that form. If you'll notice here, this -4 in front is going to be an issue. Now, you could take this -4 and bring it up as an exponent, but let me tell you, that is going to make your life way harder. Instead, let's think differently. If we divide both sides by -4, we can cancel out this -4 over here, and then it's gone. So we would have log base 2 of 5x is equal to 3. I do the loop-de-loo. Start at the base across the equals back again. Yeah, maybe I'll do my loop-de-loo in a different color this time. Let's do purple. That sounds fun. Loop-de-loo, start at the base across the equals back again. We get 2 raised to the 3rd power is equal to 5x. To solve for x, we're dividing both sides by 5. And we get x is equal to 2 cubed is 8 over 5. This should be an answer. We're going to check to make sure that it doesn't give us a domain issue. Probably shouldn't have boxed it, right? I should check first. All we're really checking when we check this is the inside of the logarithm. That's the only thing that matters. I don't need to plug it back in to see if the answer comes out correct, though that's always a good idea. What I need to do is plug it in to see if the inside of the logarithm comes out to be a negative number or 0. So inside of log, we have 5x. That's the only thing inside of a log. So we're going to plug in our number. We're going to plug in our answer, 8/5. For x, and indeed that comes out to a positive number. It comes out to the number 8. The fact that it's 8 doesn't matter. It's positive, and that's what matters. So we can feel good about that answer. Let's look at the next one. All right, this is already in the form log equals a number. So I'm going to go straight to my loop-de-loo. Start at the base, across the equals, back again. We get x squared is equal to 4x plus 12. Right now, I have a quadratic equation. Right? I have an x squared, I have a 4x. This is going to be a quadratic equation. I want to bring everything to one side and then factor it like a quadratic. So I have x squared minus 4x minus 12 equal to 0. That I got from moving 4x to the other side, moving 12 to the other side as well. This factors into x minus 6 times x plus 2, giving me two potential answers. I get x equal to 6 or x equal to negative 2. Now, if you are staring at this and thinking, I don't know how to do this, you're going to need to go back and look at quadratic equations. You're going to want to go look at some videos. You can find them on somewhere on Canvas. It's, I think, linked from the home page. It says algebra refreshers. Look for it. There's definitely videos on how to solve quadratic equations. Or go on YouTube and look for videos on your own. You need to know how to do this. You need to know how to factor. All right, here are my two potential answers. Now, I need to check in two places in this particular problem. Because we have an x in the base, we need to check there, because we can't have a negative base or a 0 base. And we also need to check on the inside. So the base is x, the inside is 4x plus 12. I have two different answers to check. So we're going to try with x equals 6. If we look at x equals 6, if you plug 6 into x, you get 6. If you plug, I'm going to move these over a little bit. If you plug it into 4x plus 12, you get 4 times 6 plus 12. 24 plus 12 is 36. That's a positive number, right? 6 is a positive number. 36 is a positive number. 6 works as an answer. Good going. There you go, 6. Let's try the other answer that we got, which is negative 2. And you might see already this is going to be an issue because when we go to plug it in to the base, we now have a negative in the base, and we can't have that. We don't have negative bases. Negative. So negative 2 is not an answer. We cannot have a negative base. So there's one answer, and it's x equals 6. All right. One more problem with just one logarithm. Once again, we're looking for log equals number. So in this case, we don't have that. We're going to have to do some algebraic manipulation to get the ln by itself. So I'm going to start by subtracting 7 on both sides. Okay, you get 15 ln of x is equal to negative 5. To get the ln x completely by itself, I'm dividing both sides by 15. We get ln x is equal to negative 5 over 15. Careful, this is not negative 3. This is negative 1/3. Negative 1/3. I need to rewrite this as an exponential, which means I need to remember that ln, here, let me write this over here, ln of x is the same thing as log base e of x. So I have log base e of x is equal to negative 1/3. Now we can loop-de-loop. So we start at the base, cross the equal, back again. We have e raised to the negative 1/3 is equal to x. And that's actually our entire answer. We're going to leave it in its exact form. I'm just going to rewrite it like this. X is equal to e to the negative 1/3. We're going to need to check this before we go forward. E to the negative 1/3, the only thing it would be plugged into is the inside of this ln. E to the negative 1/3 itself, if you plug it in a calculator, you're going to get the number 0.7165. You're going to get a positive number. So this thing right here is approximately 0.7165-ish. That's a positive number. So when I plug that into x, it's going to be positive. So we're good. E to the negative 1/3 is positive. If we plug it into ln x, we'll have a positive on the inside, so we are good to go. This right here is our answer. All right, and that's the start. That's the start to it. All of these problems right here were type A problems. We will be getting into multiple logarithms, which will then have type A and type B problems, but that'll be in the next video. If you have questions, send me an email. Otherwise, I will see you in that next video. Bye.